Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Yeah, so hello everyone. How are you all? Very good evening to everyone who are present here. And yeah, so I would request everyone, all of you, to kindly put a +1 in the chat box, or you can write your name, so that I could get to know that who are the people who are attending today's session, and then we can very quickly start. Hello Rishit, how are you? Thanks a lot for coming today as well. And today we will be continuing with stacks and queues, which we started in the previous week, and tomorrow as well we will be continuing with stacks and queues. Okay. Yeah, just like Rishit, I would request everyone to kindly do a +1 in the chat. Hello, Nirupama. How are you? Okay. First thing first, let me give you a small intro about just a minute. Yeah, sorry. Hello, Shiva. Yeah, apology for the inconvenience. First thing first, let me tell you what exactly is the series about. So, the series is focused upon practicing questions which are related to SDE interviews. I will be going topic wise every week, and I will be picking up the most frequently asked questions or the important concepts which are frequently used, and I will be discussing them in a live session. Okay. So, these sessions will be usually around 40 minutes to 1 hour, somewhere around that. And in today's session, we will be discussing specifically about stacks and queues. Okay, we started stacks and queues in the previous week, and we are continuing it today. Okay. Apart from that, we have a course called Complete Interview Preparation, which you can basically purchase if you are preparing for your interviews. Because that particular course has been created in such a well-crafted and structured manner that it contains all of the important topics, concepts, which are very frequently asked in interviews. Okay, and in fact, that is a very precise and to the point course. Okay, so like the return of investment will be really great in that course, because that course will definitely not waste your time, and you will get to revise everything which you want, and it can make you interview ready in a very quick amount of time. Okay, so that was about that course, and you can find the link in the description. So let me share the screen once. Let me know if my slide is visible. Yeah, and the students who joined late, I would request you all to kindly do a +1 in the chat, and also stay with me till the very end. Okay, today the session will be around 30 to 40 minutes at max, 40 to 45 minutes at max, and won't be very long. Okay, so is there anyone who are in the second years right now and will be appearing for their interviews after 4 or 5 months, like in the next upcoming interview season? Anyone out there? Or in fact, anyone who are preparing for their placements or any other interviews for that matter? You can write that in your in the chat box. Okay. This was from the previous session. We discussed about how to implement a min stack problem. Okay, so min stack was a very famous question on stack, and I said that if you are appearing in an interview and you would like to have a question on stack, the interview there is a 90% certainty that the interviewer will definitely choose this question because it is a very to the precise question, and you must understand the concept behind that question in order to be able to properly explain that question, because the intuition is the most important thing in that question. If we just memorize the concept and how to solve this question, you will not be able to explain it properly. So this was a special question which I discussed in my previous session. So you can read about more about this on GFG article, and if you would like to revise, you can watch the previous recorded video as well. Okay, so this was about min stack problem. I also told about other stack-based problem like rainwater trapping problem, histogram, parenthesis matching problem, LRU cache and LFU cache. I hope the students who were there in the previous session did had a go through on these problems itself. Yeah. So students who have joined late, I would request you all to kindly do a +1 in the chat so that we can very quickly start. So this was from yesterday's session, and you will find a slide in the description of the video of the previous session. And in fact, let me give this slide in this session as well. So because I will be writing in this session in this link only. Okay, Shiva, all the best for your preparation. Hello, Akash, how are you? Okay, so this is a link to the slides. You can check out the previous. Okay, so let us start with today's concept. So today we will be doing a problem which is actually not a stack problem. Okay, but in fact you will find that problem in graphs. Okay, but since this involves stacks and this is a series for SDE interview preparation, so I'm assuming that you guys also know graphs as well. Okay, so since we are only discussing problems, so I thought of taking this out of box problem. Okay, so the name of the problem is rotten oranges. Okay, and can anyone tell me a graph algorithm that uses stack or queue? Stack or a queue? Can anyone tell me a graph algorithm that uses a stack or a queue? Anything? Anyone out there? BFS or DFS? Okay. Hmm. Like DFS doesn't necessarily, we don't need to use queue in BFS or a DFS. Okay, basically this is a recursion algorithm. Okay, and whatever concept that we are trying to apply using DFS will be created in the stack space. Okay, which is basically follows the concept of last in first out. Okay, but I was thinking about more specifically breadth first search, BFS. Okay, in this question we do need a queue. Okay, so today we will be doing a rotten oranges problem, which in fact will be solved by BFS. Okay, that is the reason I'm taking this concept today. And let me share the link of today's problem with you all. Hmm. So the problem statement says that you are given a grid of dimension n into m, where each cell in the grid can have values either 0, 1 or 2. Okay, which has the following meaning. So if the value in the cell is equal to 0, it means that it is an empty cell. And if it is equal to 1, it means that it has fresh oranges. And if it is equal to 2, it means that it has rotten oranges. Now you have to determine what is the minimum time required to rot all the oranges. A rotten orange at index I, j can rot other fresh orange at indexes I minus 1j, I plus 1j, I j minus 1, and I j plus 1, which is basically the top, down, the left, and the right in a unit time. So let's say if at particular index I comma j you have got a rotten orange, so in 1 second or in 1 unit time it will be able to rot all the four four near oranges. Okay, so the four near oranges are basically the oranges present in the top, down, left, and right. Okay, so let us say that you are given this grid, and in that case the grid will be something like this: 0 1 2, 0 1 2 once again, and then 0, 2 1 1. Okay, so after that you will be having the oranges are at position 0 comma 2. So basically the oranges at position 0 comma 2, so 0 comma 2 will be equal to this one, and then 1 comma 2 will be equal to this one, and 2 comma 0 will be equal to this one. So these are the oranges which are basically rotten in nature. So these oranges will try to rot its nearby oranges. So in 1 second, what will happen? This particular orange will rot this orange, and this particular orange will rot this orange and this orange, and this particular orange will rot this orange. So basically, after 1 second, this entire basket is getting rot. Okay, all the oranges are getting rotten. So yeah. So is there anyone who can just tell me a small approach? Tell me the exact approach about how to solve this question in a very brief manner. Okay, how we will be applying the concept of BFS to solve this question, and more specifically, where we will be requiring the use of stacks or queues in this question. Okay, I'll give you a very big hint that we will be solving this question with BFS, and in fact, it is a very famous problem involving uh, gra- graph problem. Okay, so in the first second, what will happen? This is a 2, this is a 2, and this is a 2. So 2 means rotten oranges. Okay, so this 2 will rot this orange and this orange. In fact, 0 means empty. So empty means there are no oranges, so nothing will happen. So since this there is a 1 beside this 2, it will rot this orange. Then this particular 2 will rot this orange, and then this orange. And finally, this particular 2 will rot this orange. Okay. Now, tell me something. If let's say I have a orange called 1 and I have zeros surrounding this orange. Okay. So is there any way that you will have this orange rot? Can you rot this orange in any way? Can anyone tell me? Hello Rishit. Hello Akash. Hello Shiva. Hello Nirupama. Can you tell me that if I have a fresh orange marked as label 1 and which is surrounded by 4 empty cells, so is it possible to rot this orange by any of the rotten oranges? Anyone? Rishit, are you there? Yeah, I would request everyone to kindly stay with me till the very end, and I will be discussing this entire problem, its approach, and the time complexity and the space complexity as well in today's session. Okay, and in fact, it is a very famous interview problem involving stacks and graphs concept. Okay, anyone, Rishit, Akash, anyone? So the question that I'm asking is that if let's say we have a 1 in a particular cell, which means that we have a fresh orange and it is surrounded by 4 cells containing empty cells. So is it possible to rot this orange by any other oranges which are rotten? For example, let's say you've got 2 here, 2 here, 1 here. Okay, 2 here. So will this 2 be able to rot this? Okay, Rishit is saying yes, Akash is saying no. Okay, so Akash, you are correct. Okay, we will not be able to rot this because since in all the 4 perpendicular directions, it is surrounded by empty cells. And as I said, in the question it is mentioned that if a rotten orange is present, it will only be able to rot the 4 directions in perpendicular. So all the perpendicular 4 directions. So this direction, this, and this, and this. So this particular direction. So this particular orange one, it has been surrounded by empty cells. Okay, so if these are empty cells, it means that you cannot have a rotten orange in those particular cells. So in short, this particular orange will remain fresh after will remain fresh. Okay, none of the rotten oranges will be able to rot this. So the question is asking that you have to tell the minimum amount of time in which you will be able to rot all the fresh oranges. And the question also says that if it is not possible, you can just output -1. Okay, So in such a case, when rotting of all the oranges are not possible, okay, so not possible to rot all oranges, so in that case you can simply output -1. So this is the entire problem statement. Let us look at the constraints then. The constraints of the problem involve that n and m, which are basically the dimensions of our given matrix, is of size 500. Okay, so 500 comma 500. So and the expected time complexity is n into m. Okay, so what type of approach we can think of? As I already said, we will be involving breadth first search and we will be utilizing the concept of stacks. Okay, so is there anyone who can just briefly tell me how we are applying the concept of BFS and how, more specifically, how we are able to get the minimum amount of time for rotting all the oranges? Okay, can anyone tell me? And for the students who joined late, I would request you all to kindly write your name in the chat box or simply do a +1. I've already given the link of the Jamboard session as well as the question session in the chat box, and you can follow along with me. Okay. Apart from that, we also have a complete interview preparation course link, which is in the description of this live stream. And at the same time, I would request you all to kindly like this streaming session and subscribe to our channel. Okay. And this is about myself. My name is Gaurav Kumar Shah. I have written. So I mentioned my name in the very first slide of this, and you can hit me up on LinkedIn if you would like to get connected with me. Okay. Apart from that, I am presently in my third year at IIT Kharagpur, and I'm also a mentor at GeeksforGeeks. Okay. So this was about my introduction. Let us move back to our question then. Anyone? You can write in the chat box if you are able to think of a brief approach that will specifically help us solve this problem. So, do all of you all know BFS? If not, I will give a small introduction about BFS and then we will proceed. If we perform a BFS from each rotten node, we can mark fresh oranges that can be reach as rotten. Once we cannot mark any oranges rotten, we stop and return time taken. Okay, that's good, Rishit. So, Rishit, can you tell me that what specifically is the use of queue data structure in solving this question? How specifically the queue data structure is helping us solve this problem? Because we are doing session on stacks and queues, and how exactly queue is helping us. Yeah. Just give me the intuition that why having queue will help us get the minimum amount of time. Okay, anyone? The question that I'm asking is that why in BFS do we use a queue, and in the problem rotten orange, why basically using a queue data structure will help us get the minimum amount of time for rotting all the oranges. And Rishit, you also made a statement that uh, if you perform a BFS algorithm, BFS from each rotten node. So let's say the total number of nodes are n, and basically the time complexity of a BFS algorithm is quadratic. So if you are performing BFS for every node, it will get a cubic time complexity, I suppose. Pardon me, just a minute. Okay, so just specifically tell me what exactly do you mean by if you are starting BFS from every node? Like, will you just repeat the BFS algorithm every time? We access the nodes at first level and then the next and so on. So we have to access node in first order. Okay. Hmm. Yeah, Rishit, you are correct. So let me explain the BFS algorithm in a very brief manner, and then we can proceed with this equation of this solution of this problem. Okay. So let's see. So BFS algorithm is basically means breadth first search. Okay. So let's say we have a rotten orange. Now this particular orange will be able to rot all the oranges which are fresh and at the four sides of this particular rotten orange. So what happens in a BFS algorithm is that, let's say we have a node and we want to do a BFS algorithm on this node. So what will happen? This node will try to visit all its neighbor. Okay, and then once you it will visit all the nodes in at a distance of 1 unit or at a distance of one level from the given node. Okay. After that, what will happen? It will again try to visit all the node at the second level, and then again all the node at the third level. So what is happening basically? We need to use a queue data structure. Initially, we will put that particular node in which from we are starting the BFS. So this particular node will go and it will look at all its adjacent nodes. So this is the adjacent node, this is the adjacent node, and this is the adjacent node. In this context, the four directions will be my adjacent nodes. It will go and check out in all the four directions that whether we have a rotten orange or a fresh orange at that particular cell, or an empty cell in fact. So whatever it is, if it is a fresh orange, what it will do, it will just insert it inside the queue. Okay. So let's say it inserted node number 1, node number 2, node number 3, okay, and node number 4. So there are 4 nodes, and let's assume that all the 4 are fresh orange. So now what will happen in the next step? So basically, in the next step, what we will do here is that this particular node will be thrown out of the queue. Now we will have only 4 particular nodes, okay, which is n1, n2, n3, and n4. N1, N2, N3, and N4. Now we will process these particular nodes. So basically, if we are processing, it means that we are basically marking it as rotten. So what we will do, we will mark these nodes as rotten. So after that, what will happen? This 4 nodes have been marked as rotten. So in 1 unit time, we have successfully marked these 4 nodes as rotten. Now what will happen? This particular node, since it is marked as rotten, it will try to look into all the adjacent node of this particular node, and it will insert it inside the queue. Then again for this element, again for this element, and again for this element. So that is the reason we are specifically using queue, because what is happening once we are inserting these particular nodes, we wanted to get removed from the queue at very first. Okay, so whatever elements I am putting inside it first, I will remove it from the first. Okay, first in first round kind of data structure, that is queue. So that is the exact reason why we are using queue to solve this problem. Okay, so yes, Rishit, your intuition is correct. But just tell me one thing that let's say there are multiple rotten oranges. So will you be applying the BFS algorithm one by one for every rotten orange, or in that case, how will you deal with the problem? I think this BFS for each one node would be very slow. No, okay, why it would be slow? Then how will you do that? Like if it is slow, then what will be a better approach? Tell me that. In fact, let me tell you one thing that let's say you take one particular node and you do a BFS algorithm. So can we try doing it all for the all rotten nodes together? Yes, you have to do it for all dot nodes together, because what is happening here, we have to calculate the minimum amount of time. Okay, the time complexity for both the approaches will be same. Let me just give you a small hint regarding this. So let's say the time complexity of a BFS is equal to number of nodes V plus E. Okay, so what does this mean? Hmm. So what does this mean? So this means that let's say, total number of edges and the vertices. Okay, so in a graph, let's say this is a graph. Okay, so number of nodes are equal to 1 2 3 4 5. Number of edges are equal to 1 2 3 4. Okay, so this will go O of 9. Okay, so in fact, what will happen here, let's say you are trying to call this BFS from this node. So it will visit this particular node, this will visit this particular node. Okay, now let's say this node is rotten. So it means that it will try to rot this particular node and this particular node. Okay, in 1 second. After that, this particular node will also get rotten, and it will rot this particular node and this particular node. Now let's say I am putting one more this particular node. Okay, so this is also rotten. Okay, so let me mark this by red. So this is rotten, and this is rotten. So initially, let's say that you started BFS with this algorithm. This in 1 second. In the first second, it will rot this orange and this orange. Okay. In the next second, what will happen? It will rot this orange, this orange. This will rot this orange. This is already rotten. So it will take 2 seconds. In the third second, what will happen? This will rot this orange. In the fourth second, what will happen? This will rot this orange. So total time we are taking is 4 seconds. Now let us do BFS algorithm together. Okay. So let me just draw the graph once again. So this was a case when we BFS algorithm one by one. Okay. So we are doing the BFS algorithm one by one. So let's look at this concept. Okay. Okay, so this is one, this is one, this is another, this is another, this is yeah, okay. So this is rotten, and let's say this is also rotten. So what I'm doing here, I'm inserting this node and this node both inside my queue data structure. Okay. Now in the first second, this will rot this orange and this orange, and this will rot this orange. So 1 second is done. In the second, what will happen? It will rot this particular node will rot this orange, and it will rot this orange. This will rot this orange. This is already rotten. Okay, right. So so this will also rot this orange. Okay, so 2 seconds are done. The third second, finally, it will be able to rot this orange. So we are able to complete our entire operation of rotting all the oranges in 3 seconds. But in this approach, we required 4 seconds. And the question was asking us minimum time. Okay, so that is the reason we will be able to. We are supposed to use multi-source BFS. It means that once we are applying the BFS algorithm, we will simultaneously apply from all the nodes which are rotten, so as to get the minimum time. So, Rishit, did you understood this concept? Hmm. Is the intuition clear that why we have to apply BFS algorithm from all possible nodes? Anyone? Okay, Rishit, that's great. So yeah, so let us now proceed to the solution part of this question. So what are the solution steps? So the first step would be to count all the nodes which are marked as 2. Okay, so basically what we will do here is that we are given in matrix form. Okay, so we will traverse all the cells of the matrix, which will take n into m time. We will count all the nodes which are 2, basically the number of rotten oranges. Then what we will do, we will declare a queue. We will push all the elements inside the queue which are rotten. Then we will start a BFS loop. Okay, so we will start a BFS multi-source BFS. Now it will take every particular node, and if it will try to move in all the four directions. So if any of the oranges which are fresh in any of the four directions, we will mark it as equal to 2. Okay, and what we will do, we will also do a count plus plus. Why we are doing count plus plus? So whatever nodes are being marked as marked as 2, which means I am rotting that node, I will increase my count plus plus. Why? Because initially, let's say I have m number of rotten oranges, okay, and the total number of oranges, let's say total oranges, which is equal to fresh plus rotten oranges, are equal to, let's say, n. Okay, let me just remove this. Let's say the total number of oranges present in my basket are m. Okay, so if count is equal to m, after my BFS operation is done, in that case, I will return the time taken. Otherwise, I will return minus 1. Minus 1 means it was not possible to rot all oranges. Is this clear? Not possible to rot all oranges. Okay. Now, one more thing. We also have to count the number of times, the number of total amount of time it is taking. So what will happen every time this loop will run is one particular step of a BFS. So initially we have it takes one node, it takes all the node of this tree, and we will do a T plus plus as well. Okay, every time the BFS algorithm will run. So every time we are moving at a different level, we will do every time like the BFS algorithm goes level by level. So in the first level we have 1 second, in the second level we have 2 seconds, the third level we have 3 seconds, and so on. So every time we are progressing down a level, we will try to increase our time counter as well. So is this clear to everyone? Okay, so let us have a look into the problem for this. So, meanwhile, the students who have joined late, I would request you all to kindly do a +1 in the chat. Apart from that, we have a course called Complete Interview Preparation. In case if you would like to, if you're preparing for your interviews, you can definitely check that course out. It is an extremely well crafted course from interview point of view. Okay. So you will find the link to the description in the chat box or in the description of this video. And we would also request you to kindly do like this session and at the same time subscribe to our channel. We also have other very different type of content that we have planned across this channel, and that will help you in your journey of preparation for your data structures and algorithm and interview, and finally getting you a job. Okay, so this was all about it, and yeah, so let us proceed to the solution part. So what I did here, I declared two variables called ct equal to 0 and res equal to -1. So now I also have to declare a queue. Okay, now why queue? Because this queue will consist of vector. So why vector? Because I will be storing the coordinates. Okay, now we are given in the form of a grid. Okay, this grid contains the size of this grid is n into m. Now, vector of vector, this is a direction vector. Okay, now the use of this vector will be to, I will be telling you later that how we are utilizing this vector to move in all the four directions. Okay, now after that we'll run a loop. So the for I equal to 0, I is less than grid dot size. So we are iterating across all possible cells of the grid. Now if it is greater than 0, if it is greater than 0, it means that it is equal to 1 or 2. If it is 0, it means it is an empty cell. So this variable ct is basically counting the total number of oranges. Okay, so I can just write a comment that I can just write a simple thing that ct is counting the total number of oranges. Okay, total number of oranges, which is equal to fresh as well as plus the rotten. Okay, and since the grid is of size n into m, the total number of oranges will not be equal to n into m. Like it may or may not happen because there might be certain empty cells. Now we will also what we will do, if that particular cell contains a rotten orange, I will push that inside my q vector. Okay, I have a q which consists of a vector. So in fact, every vector of the q will contain two elements also. So we could have also used a pair as well. Okay, also a pair of q of pair. Okay, queue of pairs could have been used. Okay, both would mean the same thing. Now what we are doing basically is that now we have our data structure ready. Okay, now we have to apply the third step, that is apply the multi-source BFS. Okay, because our the BFS algorithm uses queue data structure, and in our queue we do not have one node, we have multiple nodes. So we will start our multi-source BFS from here. So I hope you guys know about the standard code for multi-source BFS. If not, I'm putting it here. In fact, the concept which I just explained previously is a direct result of multi-source BFS. So we will run a loop, and while the loop is not empty, which means that while q is not equal to empty, we will do a rest plus plus. Okay. Now what we will do in size equal to q dot size. Hmm. Okay. So what we are doing basically here is that as soon as we are entering into the while loop, we are increasing the rest plus plus. So rest is basically the result counter. Now what will happen? So why we are increasing the result plus plus? Because result is basically the time which we are trying to print. Okay. Because finally we are returning. Yes, we are supposed to return rest. Okay. So finally we will be returning the result. Okay. So now what will happen? We are iterating across all the elements of the queue. That is the reason we are running this for loop. Now, what we are doing, we are taking that particular element and removing that from our queue as well. And at the same time, what we are doing, we are traversing in all the four directions. So this loop is running four times. It is going across all the four direction of the direction array. Okay, which we just specified. So this direction array is basically helping us traverse the four direction, because let's say we are standing on I comma j, we have to traverse I minus 1j, I plus 1j, I and j minus 1, and I and j plus 1. So with the help of this direction array, we are able to get in the four direction. As you can see, current of 0 plus direction of I comma 0, current of 1 plus direction of I comma 1. So this current vector is consisting of the present element in which we are standing. Now we are just checking that whether that particular grid is possible or not. If it is possible, we are just huh, like if x is greater than or equal to grid dot shape. Yeah. So this is basically checking that if it is possible or not. So if it is not possible, it means that you are just going outside your grid. So in that case, what will happen? You will do nothing. You will just continue because that is an invalid cell. Okay. And if it is not, it means that it is a rotten orange. That there is a valid orange in that place, and you will just rot that orange. So let's say you just rot it. And finally, what will happen? Since you rot a orange, you will push it inside the queue. Why you are pushing inside the queue? Because once you rot a particular orange, that particular orange become capable of rotting other particular oranges as well. So in the next iteration, what will happen? That particular orange will also rot other oranges. Okay. It doesn't mean that once you rot a orange, you will stop here, because you have to find the minimum amount of time, and every rotten orange will rot all the rotten oranges of its neighboring side. Okay. So that is the reason we are once again pushing inside the queue. So it is going back of the queue. Once again, from the front we are popping it, and from the back we are inserting it. Okay. So this is how entirely it is working. Now finally, what we will do, we will check if. Okay, let us see that there are certain doubts here. Line 53, what does grid x comma y not equal to 1 mean? Okay, so Rishit is asking a doubt why grid x comma y not equal to 1 means. So not equal to 1 means what was signifying 1? 1 is basically fresh oranges. Okay, okay, 1 is signifying fresh oranges. Hmm. So 1 is signifying fresh oranges, and so basically what you have to do here, let's say that you are going to any particular cell, and if it contains a fresh just a minute. Yes. So one basically means fresh orange, and if a particular cell you are going, and if it is not a fresh orange, then it means that you will not rot that orange. So it is already a rotten orange, or in fact it is an empty cell. So in both cases you are supposed to continue, because let's say if it is an empty cell you cannot do anything, and if it is already a rotten orange, it means that it is already inside a queue. So you are not supposed to re-enter that particular number once again inside the queue. In that case, what will happen? This will become an infinite loop. Got it? One is basically a fresh orange, and if let's say why you are checking that, because you don't want the BFS algorithm to run into an infinite loop. Okay, because if you're not checking for the rotten orange, the fresh orange, what will happen? It will just rot already rotten orange, and it will just re-enter back it inside the queue, and this queue will run forever because it is never getting empty. The exiting condition from the queue is that it should become empty. Once it is becoming empty, we will exit the queue. And finally, what we will do, we will check if count is equal to 0 or not, because we are decreasing the variable value count. So count was the total number of oranges in the present, which is equal to fresh plus rotten. And for every iteration that we are doing inside the queue, every time we are popping an element out, means every time we are processing an orange, we are decreasing the value of count. So after this entire operation gets over, the count value must be 0. It means that we have processed all the oranges. If the rotten oranges were already inserted into the queue, and the fresh oranges already got robbed. Okay, so if CT doesn't become equal to 0, it means that there had been a case which means that there is a fresh orange and we were unable to rot. So that can only arise because if a fresh orange is surrounded in 4 directions, either through an empty cell or the boundary of the matrix. Okay, so it means that any particular rotten orange was not able to reach that particular cell. So if that is the condition, we will return -1. Okay, so let us submit this problem and see whether it is correct or not. Okay, so there is a small compilation error. Okay, so I'm supposed to put it inside comment. Yeah, so as you can see, all the test cases have passed, so therefore this problem is correct. Okay, so line 63, why do we take max of 0 comma s? Okay, so let's say that count is not equal to 0. So it means that what will happen if count is not equal to 0? uh, where is the result here? Result plus plus. Okay, yeah, initially we did result equal to -1. Okay, that is the reason. So let's say you are getting a condition in which all the oranges are already rotten. Okay, so it means that it actually took 0 second to rot all the oranges. Okay, but after the multi-source BFS, the count will also be 0. Okay, so in that case, what will it return? If we, let's say we return just res, so it is returning -1 instead of 0. Okay, because we are initializing res with -1, so we have to take maximum of res or 0. So if res is a valid answer, it will be either 0, 1, 2, whatever it is. So in that case, it will be res. Okay, and we just don't want -1 to get printed in case of a correct answer. So that is the reason we are taking res equal to max of 0 comma res. Got it? Okay, Rishi, that's great. It got clear. So yeah, we have successfully solved this problem, and we saw how exactly the application of Q in this graph problem. Okay, so when we will be discussing graph, I will certainly be not taking up this problem because it is already done. So I will be taking up other difficult problems when we will be discussing graph. Okay. Yeah. So, do you guys have any question? And meanwhile, the students who have joined late, I would request you all to kindly check out the complete interview preparation course, which is there on our GFG portal itself. And it is an extremely well crafted course and structured course for if you're preparing for your interviews. Okay. Apart from that, I have already shared the link of the Jamboard session and the question session in the chat box. You can check that out. And this particular Jamboard session also contains a very important problem which I discussed in my previous session in the previous week. Okay, which was basically implementing min stack. So if you are able to If you could successfully look into both the concept, it will be really great because that particular question is very frequently asked in interviews these days. Okay. So if you guys don't have any questions, so let us wa- mm, let us end our session here. Rishit, do you have any question? So did you all enjoy today's session? Hello, Rishit. Hello, Pushpendu. Rishit, were you able to learn something from this today's session? For the next session, could we try basic calculator problem? Basic calculator problem. Let me look at that problem. What exactly it is? Can you send me a link? Rishit, I'm waiting. Can you just send me the link of the problem, basic calculator? If it is a stack and queue based problem, I will definitely be solving it. Just send me a link. Okay, yes. Give me the question. Is it this question? Create your calculator. Rishit, are you there? Tell me. Is it this question which I just a minute? I'm giving you the link. I'm sharing my screen once again. Just let me know that if it is that particular question which I have selected. Sorry. So Rishit, is it this question? If it is this question, I will definitely be discussing. Okay, so I have to check if it is a stack and queue based question only. Then I will be discussing. Can you send me the link of the question that you wanted me to discuss? Is it on which platform? Even if it's on LeetCode or anything else, you can just share the link. I will definitely discuss the approach tomorrow. Hello, Rishit. I am waiting. Hello, Rishit. Yes, yes. I can see the chat box. You just put your link in the chat. Okay, yeah. Give me the link. Okay, okay. Basic calculator 3. Okay, I'm searching for it. Okay, got it. I will discuss that tomorrow. Okay. Okay then. Let's wrap up our today's session, and tomorrow we will be discussing stacks and queues once again, and we will be discussing Rishit's problem on basic calculator. Okay. Okay, Rishit, welcome. Okay then. Bye bye. Have a good night.